Okay. So, good morning, guys. Welcome to NEET World Institute and NEET World YouTube channel. So, yes, in this class we will solve the little complicated problems in the laws of motion. Like complicated in the sense like how that problem can be reduce the how can we reduce that complication. We'll see. Okay. So, we'll see from the basic problems. Okay. Yesterday we were talking about without acceleration. Now in this problems whatever we are seeing, we will find how to find the acceleration and what is the acceleration of the given system, and in the pulley problem also we will see everything. Okay. So, let us start with our questions. Okay. So, the question is, so there are three blocks. So, mass 1, mass 2 and mass 3. Let me write that masses here. So, question, M1 equals to 1 kg, M2 equals to 1.5 kg and M3 they have given as it is 2 kg. Okay. So, these are the masses they have given, are in contact with each other on the frictionless surface, which means they are told that masses are contact in the frictionless surface. So, this surface is frictionless. Okay, this is frictionless surface. Let me take the masses. This is my M1, M2, M3. Okay, up to this the question is clear. No, the next part of the question, find the horizontal force F needed to push the block in a single unit. Find the horizontal force they are asking. Okay. So, the acceleration they have given, the acceleration is A is equals to 4 meter per second square, 4 meter per second square. Okay, sir. So, this is the thing. So, 4 meter per second square. First question is find the force, the external force need to apply on the box, then the box will go with 4 meter per second. Okay. First question, external force. Second question, the normal force between the blocks. So, this is my questions. Okay. So, what is the thing? I will consider the force is applied on M1, which means I am applying a force here. So, obviously the block will move in this direction, right, in the right direction with an acceleration 4 meter per second square. Let us derive that. See, yesterday I have told in a simple method, acceleration is nothing but force by the total masses M1 plus M2 plus M3. So, this is the simple way to write it, because whatever the problem in this kind of thing they have given, this is the formula. Like if 2 masses is there, M1 plus M2. If n masses is there, M1 plus M2 plus up to Mn. Now we know that force I need to find. Acceleration is 4 meter per second square. Mass 1 is 1 kg, mass 2 is 1.5 kg, mass 3 is 2 kg. 1 plus 1.5, 2.5, 2 plus 2.5, 4.5. So, 4 into 4.5. So, 4.5 2 times 9, 9 2 times 18. So, 18 Newton is the answer. This is my force. Got it? So, if someone having any doubt here, let me do here. Okay. So, this is my, suppose if I consider the force is acting like this. So, M1, the force, external force F, and the normal force will be there N1 on M1. Okay. Next, I will take M2. So M2, one normal force is there, that is N1, other normal force is there, that is N2. The next case is M3, one normal force is N2. Is there any other normal force? No, that's it, only in x direction I am talking. So for everything acceleration is in this direction only, for everything. Right now acceleration 4 meter per second square. If I want to write the equation, can I write the equation? No. In the direction of acceleration forces are positive, in the opposite direction of acceleration forces are negative. So F minus N1 will be equals to M1A. Next is N1 minus N2 will be equals to N1 minus N2 will be equals to M2A. N2 will be equals to M3A. Add everything, N1, N2 and will get cancelled off. Minus N1 plus N1 minus N2 plus N2. So F will be equals to, add everything, M1A plus M2A plus M3A. Take A commonly outside, A into M1 plus M2 plus M3. What I will do here now? I will take I need to find this only, no. So F4 into 1 plus 1.5 plus 2. So which is nothing but 4 into 1.5, how much? So 15 4 plus 6 and plus 8. So 10 18 Newton. Am I getting the same answer? We are having the same formula. If you see, F into A, F is equals to A into M1 plus M2 plus M3. We are having the same formula, like I have given the formula directly here. Since we have derived the formula in yesterday's class, I have given it. But if anyone having a doubt, this is the way of doing. This is the way of doing the question. Okay. So the first question has been completed. The external force, how much? 18 Newton. What about the normal forces they are asking? Normal forces in the sense, whatever the force acting between M1 and M2 and the force acting between M2 and M3. That one I need to find it. Right? Okay. So if I talk about the normal force, let me consider the same equation. What was the equation here? F minus N1 equals to M1A, N1 minus N2 is equals to M2A, N2 is equals to M3A. Sir, if you find here N2 is equals to M3A, can I write it as it is? Because M3 I know, A I know, right? No, normal force 2 will be equals to M3A, where M3 is 2 kg. Yes, no, M3 is 2 kg, acceleration is 4 meter per second square, which is nothing but 8 Newton. Normal force 2, that is a force acting between M2 and M3 is 8 Newton. What about the force acting between M1 and M2? Let me find here. Either you can use the first equation or second equation. So let me take the first equation. F minus N1 will be equals to, what is M1? 1 kg and it is 4 meter per second square, like acceleration is 4 meter per second square. So what we know? F we know, 18 minus N1 will be equals to 4. So 18 minus 4 will be equals to N1. What about N1? N1 is equals to 14 Newton. So this is N1 and N2 is equals to 8 Newton. This is about my normal forces which is acting between the blocks and the external forces 18 Newton. When 18 Newton is applied, the blocks will go with the acceleration of 4 meter per second square, right? Okay, we'll go for the next question. Completed? So the next question. 3 blocks are connected, pulled by a force as shown in the given figure. I will draw the figure first, then you will try to understand what is the diagram they have given. So they have given, there is a mass M1 and in between M1 and M2 there is a rope. So this is M2 and again one more block is there, this is M3. So a force is applied here. Okay. So acceleration of this will be obviously in this direction, because since the external force is in this direction, I can say that acceleration also will be in this direction only. Okay. So they have given this one, they have mentioned as T3, and this is T2, and this is T1. T3 they have given as 120 Newton, M1 they have given as 5 kg, M2 they have given as 10 kg, M3 they have given as 15 kg. Calculate the acceleration and the tension T1 and T2 in the system. Calculate the acceleration. The question is calculate the acceleration. Second question is find the tension between tension T1 and T2. T1 and T2. This is my question. I hope you got clear about what they are trying to give in the question. Right now, there is a block, 3 blocks. So in between the blocks, there is a rope, which is nothing but normal force is not there, tension will be there. When external force or another rope is there, which is pulled like this, which is nothing but T3. So when we are pulling the blocks like this, acceleration also will be in the same direction only, right? And it's a frictionless surface they have mentioned. It is a frictionless surface. So in the previous question also I have mentioned, I guess it's a frictionless surface. Frictionless surface only. Okay. T3 they have given, M1, M2, M3 they have given. Okay, let us try to analyze the free body diagram of the given question. Let me take this block M3. So when I talk about block M3, tension T3 is acting like this. Obviously T2 will be acting away from the body. Which is away from the body? This is my away from the body, T2. Got it? The next one, M2 I need to find, right? So let me take. This is my M2. So T2 and T1 acting, both are away from the body. T2 will be in this direction, T1 will be in this direction. The final one is M1. So for M1, only one tension is acting, T1. So we have drawn the free body diagram. Try to mention the acceleration direction. This is my acceleration direction, this is my acceleration direction, this is my acceleration direction. Okay, second step also completed. Now third step, we need to write the equation. Whenever we are writing the equation, try to see the acceleration direction. In the same direction, whatever the force are acting, that force is positive. In the opposite direction, whatever the force are acting, that is negative. So which is nothing but, for this one, T3 minus T2 will be equals to M3A. Okay. Then T2 minus T1, no? T2 minus T1 equals to M2A. Then finally T1 will be equals to M1A. So if you find the equation like this, what you will do is try to add everything, plus and this plus. If I add everything, minus T2 and plus T2 will get cancelled off, minus T1 and plus T1 will get cancelled off, T3 is remaining in the left hand side, should be equals to, everything is added up. So M3A plus M2A plus M1A. What I should do? Take A commonly outside. M1 plus M2 plus M3. Correct, no? M1 plus M2 plus M3, which is nothing but T3, equals to T3. So I need to find acceleration. Then only I can find the tensions, right? I need to find the acceleration also, first question. I can find it easily. So should be equals to T3, how much? How much they have given T3? 120 Newton. 120. Okay, let me write the equation first. So T3 divided by m1 plus m2 plus m3 should be equals to 120 divided by 5 plus 10, 15, 15 plus 15, 30. So 1 0 and 1 0 will get cancelled off 1 times and 4 times. So answer is 4 meter per second square is my answer for the acceleration. Got it? Once you see, like if you are having any doubt, you can ask me. Okay, then we'll go for the next question. We need to find the tension, right? So we got the acceleration. So now the tension T2 and T1 I need to find. So T1 I can take third equation. This is my first equation, this is my second equation, this is my third equation. I'll take the third equation as it is. From equation 3, so T1 will be equals to m1a. What is m1? m1 is 5 kg. And what about the acceleration? 4 meter per second square. So answer is 20 Newton. The next one, either you can use the first equation or the second equation. So let me take the second equation there. From equation 2, if you see, T2 minus T1 will be equals to m2a. T2 will be equals to m2a plus T1. Got it? What is m2a? What is m2? 10. 10 kg into acceleration 4. What is T1? T1 they have taken like this, no? So T1 how much we got? 20 we got. So 20. So 4 into 10 is 40. 40 plus 20, it is 60 Newton. So T2 we got, T1 also we have, T3 also we have. So acceleration equals to 4 meter per second square. T1 is equals to 20 Newton, T2 is equals to 60 Newton, T3 equals to 120 Newton. This is my answers for the questions. Done? Okay. We'll see next question. Okay. So let us do this question. So there is a inclined plane. Okay, they have mentioned the angle 30 degree. So there is a pulley over here. Okay, there is a pulley over here, and they have given that here they have given 4 kg block, and one more block they have given here. This is 8 kg block. So attached like this. We need to find what is the acceleration of the block. Okay, sir. Let us see here what is the thing they have mentioned first. Okay, inclined 8 kg, 4 kg. What happens when more weight is here? If instead of 8 kg, 4 kg here and here 4 kg and here 8 kg, which means the block will come down like this. Here it is 8 kg now and here it is 4 kg. It will try to come like this now. If it is coming like this, what about this one? It will go up. Got it? So this is my acceleration direction. First we got the acceleration direction. Next thing, I need to find whatever the forces are acting. So when I talk about this 4 kg block is there, no? When I talk about this block, I will draw the free body diagram as it is. Free body diagram of the 4 kg. Whatever the forces are acting, one is tension and one more is the weight, 4 into g. 4 into g, like mass into like gravity, right? And the acceleration direction is towards up. Okay, we got the acceleration direction too. Now what about this one? Now if I talk about the forces acting here, one is normal force and one is the weight 8g, but normal force is not equals to weight here, no? In this case n is not equals to mg. Got it? I need to find that one. First, if I find this, I can get this also. What is the trick I have told to find? Take 8 parts. Take 8 parts. Okay, we have taken 8 parts. If I consider the same one, can I keep it here? Which is nothing but this is my 30 degree. And what is the forces are mentioning here? Like before that, keep mention the 30 degree angle alternatively. Alternatively I mentioned. Now mg is acting towards down, that is 8g acting towards down. The normal is acting in this direction. The normal. Either I can get the normal or either I can simplify the 8g. So the angle which is closer to the axis, which is nothing but cos theta, that is 8g cos theta. Now I can say that n will be equals to 8g cos theta. If this is 8g cos theta, obviously this one will be 8g sin theta. So can I say that this is my 8 into 10 into sin 30 degree and this is my 8 into 10 into cos 30 degree, and we are not talking about this one now, we are talking about this. So 10 like the force is acting towards down, tension is in the opposite direction. Got it? Force is acting towards down, tension will be in the opposite direction. Now what will be the free body diagram and what will be the equation can I write there? For this, if I write the equation, T minus 4g equals to 4a. T minus 4 into 10 will be equals to 4 into a. Got it? And what about this one? 8 into 10 into sin 30 is 1 by 2. So 8, 10, 1 by 2 minus, tension is in the opposite direction, minus t will be equal to how much? 8 into a. Got it? 8 into a. Yes, we are writing only the acceleration here, okay? No need to solve anything here, that's it. If I add everything, what happens? Minus t plus t will get cancelled off 1 times and this is 5 times, 8 5s are 40 and yes, sorry, this one acceleration I need to write, no, this also. If you talk about here, no, acceleration, right? Yeah. So here I will mention the thing, note point, see whatever the mass can be, okay, acceleration will be g sin theta. Mass can be anything, but acceleration is g sin theta. What is g? 10. What is sin 30? 1 by 2. So acceleration is 5 meter per second square. Sir, మరి ఎందుకు సార్ ఇన్ని steps? Because if we want to find what is the tension, we need to know how to derive the diagram, no? So that's why I have explained. Sir, మరి ఎందుకు a is equals to g sin theta అని చెప్పారు? I'll tell. It's a simple thing. This is the given system, no? If I talk about the block like this, obviously if I keep a block, it will come down. So this is my mass m, and this is my mg. What is mg? Cos theta, and this is my mg sin theta, and my normal is this one. So mg sin theta, force, no, this is my force. So mg sin theta will be equals to mass into acceleration. So m and m will get cancelled off. A will be equals to g sin theta. So in the inclined plane, acceleration is always a is equals to g sin theta. It is independent of mass. Any mass can be, any number of mass. The acceleration is g sin theta. Got it? So this is about the problems which we have covered today. So in next class we will bring some more problems in the laws of motion, and we'll do some more questions based on the pulley problem also. Okay, so with this I'll take a break from you guys from today's class, and we'll meet in the next class. Okay, take care, bye bye.